All right. I hereby call this general meeting, the Homebrew Robotics Club February, to order. Sorry for the technical delays. Let's get this party started. First thing we do, order of events, is robot news. Does anybody have any robot news out there they would like to share? Oh, I do. Let me share my screen. I think this got talked about in our chat. Is this Aloha robot?
Yeah.
And this is at Stanford. Stanford, I guess that's the robot lab there, huh, Tony? But they're training the robot with a Waldo, and it's learning to do mobile manipulation. You know something about this, right, Alan Tim?
Yeah. This is the mobile manipulation.
It started with the Aloha project, so they have a whole room with desks and two direct ViperX manipulators. And then they have two that they operate as part of teleoperation behind. And they just recently, was it Google, or at least maybe Google funded, decided to put it on a mobile platform, and using deep learning and hundreds of examples, it's actually been trained to do things like cook shrimp, all kinds of useful stuff that they've been teasing us would be possible since we were kids. The robot's finally doing it for real. So yeah, a lot of exciting stuff with Aloha and Aloha Mobile.
I'll put this link in the chat. You don't have your CAD drawing queued up any chance, do you?
Sure. Yeah. Give me a second, and then
Okay. I'll just go on with the new. Let me put this in the chat first off, and I'll put this in the HBRC mailing list for reference also. But so also there's in the news, Hello Robots just released their version 3, and they have an interesting actuator. They have an interesting linear actuator. There's been some discussion on the mailing list about this. Now, this is the Hello robot. Okay, and look at that gripper and look at that linear actuator. Okay, and they were doing interesting things with it using two, mobile grippers. I'm sorry. What?
What the hell?
We're only looking at one page of yours where it says this, some photos of your robots. And
Oh, I'm sorry. Okay, so it looks like the screen share is gone kaput. Let's try it one more time. And I'll put the link in the chat again. Can you see that?
yeah.
Okay, so this is Stretch. This is Hello Robot, the new robot Stretch 3. It's only $25,000. I guarantee there's not $25,000 worth of parts in there, but oh well. Let's
But it's a vacuum.
let's put that. Yeah, it vacuums.
It vacuums?
Yeah. Let me get that in the chat. I'll put the link in the chat, and again, I'll put a summary of this in the mailing list. So yeah, look at this Hello robot, and let's move to the next news item here. This is Meta's robot does the one-shot pick and drop. Okay, and so let's see if I got it here. I hate this thing. Don't get me grumbling. Okay, here's Meta's OK robot. Now, you tell me.
We're still looking at Stretch there.
Okay, let me stop. Well, you may still be looking at Stretch when you look at OK robot from Facebook. Okay, can you see that? I'm on VentureBeat now.
Yeah.
Okay. See this? This is OK robot, and this is from Facebook, and they're touting vision language models where the robot's recognizing something and they're telling it to pick and drop in an unknown room, unknown items and unknown spaces, and having some success with it. But I'm here to tell you, that's the Hello robot. It's the same robot.
Hello robot.
I get your joke.
Yes. Stretch is the new PR2.
And so here is OK Robot. It's the same robot, right, Tony? Look at it.
It is. The paper probably says it's a Hello robot. Hello robot's the new PR2.
Okay, that's good. That's cool. So this is doing some visual language manipulation where they're putting it in an unknown environment, and they've told it, generally what to do: pick up detergent, drop in red bag, and the robot's figuring that out. Through AI. So that's exciting. I'll put this link in the chat also. And I'll include it in an email later or on the post to the mailing list. What else? What else in robot news is out there? There's one more. It's kind of a big one even. Everybody watch that lunar landing?
That hop, skip, and jump one?
That was pretty exciting. Somebody forgot to unlock the safety on the LiDAR. You had one job, but apparently they had an experimental Doppler LiDAR on board. I don't know that was completely by accident, but they had one revolution around the moon to patch that in. They came down, from what I understand, at like 6 miles an hour. So it was a soft landing, but apparently it tripped and fell over on its side, and it's propped up by a rock because it's like horizontal. But most of the payloads work, and but I thought it was pretty cool that no pressure here. Somebody had to patch in the experimental Doppler LiDAR in the meantime. There was some talk about that on the mailing list too.
That was a NASA experiment for Artemis, that when they go to the moon, and they just had that kind of added on to the side, and they ended up using it. That was pretty amazing to do that in less than a day and come up with a software change like that. It's incredible, really. When it landed, it actually broke a leg. They broke a leg on it.
Okay.
There's a picture of that now on the internet.
Okay. I can't help but think that somebody at NASA, thought that they might need to patch this in case of a backup. But still, that's like Apollo 13, Neil Armstrong, taking manual control of the Eagles kind of stuff. The right stuff, I guess you might say. Here's Dr. Bott speaking of the right stuff. How you doing, Alan?
Doing okay.
All right. Okay is good. All right. What else? Robots in the news. Any more robots in the news this evening?
I think Apple just gave up on the electric car autonomous.
I saw that. Yep.
Oh, hey, I have some news.
Shoot.
Silicon Valley First is Saturday and Sunday in San Jose. It's very unusual. They've always had it at the end of April or the beginning of April, and now they're having it in week 1. So it's at the county fair off Tully.
Is that the first robotics?
That's the first robotics. And the
Okay.
game is absolutely wild this year. They're shooting rubber donuts that are called notes. And what do they have to? They have to shoot them into.
What are they calling them, Alan?
Notes, N-O-T-S. It's a musical theme. So these notes are like big rubber donuts that are around like 14 inches. So they're squishable. So they're kind of hard to throw, sort of like a closed horseshoe. So actually one part of the game is a human player has to sort of do a cornhole with it, only if the robot is hanging onto a chain and that multiplies the score. So it's a cool game. So the only thing is that you're gonna have to pay for parking. Because and parking is hard, so, and they actually, what is it? They actually are doing setup starting, they probably started today, and Thursday evening, the teams are gonna be loading up. And practice starts on Friday. So I don't know if they still need volunteers. They have around 130 people there already. I'll be there judging, so,
Send something to the mailing list, Alan.
okay.
Okay, all right. What else? Any more industry news? All right, let's move into club news, I guess more local news. Robo Games, April 18th through the 21st. Don't forget to register. I'll post some links in the mailing list. I'm going to be there for Robo Games again. That's so exciting.
Yay.
Yay. Thank you. Thank you very much. Also, Robots on Ice, scheduled on the 21st, also the same day as Robo Games. So there'll be that too. So, Thomas, we might have Simone out there on ice, or Betty Nine.
Yeah, probably Betty Nine. She travels a whole lot better than Simone.
All right, very fine. What else? Club news. Any more club news out there? Next month is our challenge month. So next month, you are responsible for a presentation. Everybody's building robots, right? We're a builders club. And so next month, you know who you are. I'll be contacting you. So go ahead, and when I issue the call, volunteer, or I'll be calling you and hounding you and volunteering you. Next month is challenge, phase 1. So very exciting. Let's do
That's a tabletop challenge.
tabletop challenge. Yes, that's the home of the original HBRC TableBot challenge. And
That
the
or Floorbot, right?
challenge and the Ormbot challenge. Pardon?
Sorry, I was just asking that. Oh, and Floorbot challenge, right? All right.
We have if you go to our webpage, and I'll put it in the chat, let's do this. If you go to our homepage, hbrobotics.org, and go to our challenges page here, thanks to Al Margalis, our web builder. Here's the challenges: TableBot challenge, Floorbot challenge, AI challenge. That's a new challenge. Amazing LineBot challenge. So we got a lot going on here. Or run what you brung. You're not limited to one of these challenges. Bring your own personal one-of-a-kind robot. And that's what we're all about here at the Homebrew Robotics Club.
Is someone gonna, as far as the line bot goes, is somebody bringing the maze, or do we need to supply a maze?
You would need to supply a maze currently.
Okay.
Bring your own maze.
Okay. I swear I did it. It does more than just this one.
Well, we'll find something. We'll cobble something together. Let's move into the next session here. It's like what I need help with. Is there a particular thing building somebody's really stressing on? The great thing about problems in this field is like you got to know a hell of a lot to be even able to phrase a question sometimes.
I have a question problem looking for help with. Anyone who knows VS Code and how to use RaaS with VS Code, I would really like to touch base with you.
Why don't you start a thread in the mailing list, Alan?
Okay.
Okay. And speaking of which, shoot, go ahead.
We doing show and tell yet?
We're going to do show and tell right now.
I did have one more question.
Who's got a show and tell?
Well, I had a little bit of a problem, like a really hyper specific problem. It's with connecting to a robot without internet, right? So I'm doing a hotspot that I connect to the robot from, right? And when you connect, I wanted to create a captive portal that is the control website. And when you're on a phone, it does it in the mini browser, right? So I'm trying to find a way of getting outside of the mini browser that phones do
All
on
right.
captive portals.
Don't want to be short with you, but phrase that question up and put it in the mailing list. Okay.
Yeah.
I'm sure there's some guys here that'll have a lot of good input on that.
Okay.
Okay. Thank
Yep.
you. Sorry about that. We were doing what I need help with, but we need to move along quickly, right, Dan?
Sure, Dan.
Okay, so show and tell. Who's got a show and tell quickly?
I got one.
Is that William?
Yeah, I got one.
William, well, let's see your show and tell.
I got two things to show. I got the
Okay,
the
you
physical
got 5
one.
minutes.
Oh, 5 minutes. So I got this robot here. This is a laser cut frame.
Can you highlight William Thomas?
Yep.
Yeah.
Am I highlighted? I don't know how to tell.
Yeah, I've got to get Thomas to highlight you. You're under the name William, right?
Yes, just William. Okay, I think I'm highlighted.
Yes, you're good. Go.
Yes. So I got this wooden frame on a robot I've been working on. And this is a web streaming robot that is prioritizing cheapness above all else. So I'm having a cost and parts around like $30, and I'm able to stream from it and control it. Now, the other part of this demo is a link. So I'm going to link in the chat a robot you can control. Tell me if that works for you guys. It should. And it's just kind of
Somebody control it at once.
Yep, it's working. I got
nice. Okay, yeah. So you should be able to just kind of drive it around.
Oh, this is too cool, William. It's blurry as hell, but it's cool.
Yeah. So it's using a relay server because I was having a lot of troubles doing like whole NAT punching and all this, but yeah, that's like the only major issue I'd guess, right? Because I wanted to do peer-to-peer really bad. So if anyone could help me, maybe that'd be a nice thing to try. And
tarball it up in a question for the mailing list.
Yeah. Yeah. So I have two methods of control currently on this, right? Because I was thinking about like, oh, what do I do if I'm at like a flea market or a trade show? And it'll create a hotspot if it doesn't find a Wi-Fi network to go on. And you can control it over that, and the frame rate gets a lot better. And then it also can connect to a router and then go to the relay server, right? And that's kind of how that's going.
This is wonderful, William. Very fine. Awesome demo.
Yeah.
What else? Is that it?
Let's see. I guess I can talk a little bit about the PCB I got. So I'm trying to, I got the, currently the setup here is ESP32 with a camera on there. I got a custom breakout board for this, which is just, you know, it's got a motor driver, and I wanted to make this kind of easy and accessible. So all the code is open source on my GitHub. I can link that maybe. And also to make it easier for someone. I'm hoping to make this into a Kickstarter, right? So
Excellent.
I haven't quite got that.
Excellent, William. Super fine.
Yeah, I got a UART connection here. So
all right.
if
That's
you want
William in Livermore. Thank you very much.
So
yeah, post to the mailing list. That's super. Who else has a show and tell this evening?
I have a quick 2-minute one update on the Orange delivering.
Go for it, Jim.
Person.
Big fan of Big Orange.
It's a minor, change from last month, or you can decide if it's minor or not. But
you got 5 minutes.
Yeah. So here, it's just a YouTube video.
Hey, Orange. Retrieve the bottle and take it to Evie.
So I said, retrieve the bottle, take it to Evie. You can see the video.
Yes, yes.
Okay, I'll search for a bottle and take it to Evie.
The audio.
Really?
Okay.
So I've been working on this a while,
I see a bottle.
and now I'm stringing together the behaviors.
I found the bottle.
Okay.
So here it switches to a lower camera.
Now I'll retrieve it.
This is using the Oak-D cameras, Oak-D stereo cameras. And it's doing an AI search, and then it uses
I
a
found the bottle. Now I'll
Is it Oak D Pro or Oak D Lite?
no, these are the original Oak-D, so it's not Pro. Then it uses a sonar sensor for the last capture portion, and also it doesn't hold it very well, but
Oh, I know that. I've done that.
well, the main part of this video is this part here where it finds the right person.
Ah,
So it's looking dead at me and it says, nope, wrong person. And then I have it rotating around, searching as it goes for the right face.
nice.
I see Evie. I'm already at the Evie. I'm releasing it now.
It didn't have to go anywhere there, but it would
Hey,
normally.
Jim, we're running behind schedule. We need to move along.
Well, that's it. That's the end.
Thank you. Thank you very much. Big Orange, ladies and gentlemen.
Thank you for the time.
Jim D'Annunzio. Hey, I understand Marco's there on site and has a demonstration, show and tell, right?
Okay.
I'd like to see that.
So there's
Is he on Ralph's camera? Am I seeing that right?
We're on Ralph's camera.
I'm on the Wi-Fi of my robot, so I can't really share the screen. So that's a 3D LiDAR scan going on in RaaS 2, and hopefully it will map in the near future. Let's see how that goes.
Whose LiDAR is that, Marco?
That's Lightbox M360.
Who?
Post in the chat.
Yeah, I put it in the chat.
All right, very good.
So it's running off Raspberry Pi 5 with 2204 and 100, and everything seems to be working fine so far.
What did that LiDAR cost?
Enough.
If you have to ask, you can't afford it. All right. Anybody else have a show and tell this evening? Sorry, we had to hurry up so much there. We're running a little late. So without any further ado, I'd like to introduce our special guest speaker this evening, Mr. Tony Pratkanis, boy genius. I've known Tony since he was 10 years old, I guess. He's been beating us in the TableBot Challenge for years. He's probably most famously known for his summer intern coffee run with PR2, where he had PR2 go fetch coffee for the professor. Tony, take it away.
Okay, it sound good?
You're
Sound
sounding
on the
good.
video?
You're sounding good.
Okay, great. All right, everyone, welcome to my presentation on how to commercialize your homebrew robot using the Robotics-as-a-Service business model. So, what are we going to talk about today? First, we're going to talk about the basics. What is Robotics-as-a-Service? What are some examples of Robotics-as-a-Service companies? We have many Robotics-as-a-Service proprietors in this room today. Why might you want to commercialize your robot with Robotics-as-a-Service? What is the revenue model like? What are the typical costs of running one of these companies? Why might you not want to use the Robotics-as-a-Service model? the scaling issues and some of the other challenges related to that. Then we're going to talk about my lessons learned from 7-8 years of consulting for robotics-as-a-service companies. How do you create and scale your own company? How do you overcome some common obstacles? And my list of lessons learned, so you don't have to learn them yourself. Finally, the future of robotics-as-a-service. Okay, so what is robotics-as-a-service? Really quite simple. Instead of selling robots like a traditional robotics company, you lease them out, and you basically are no longer selling robots at that point. You're providing services using robots. Okay, so what are some examples of currently extant robotics-as-a-service companies? Number one we're going to talk about is Brew Robotics. Brew Robotics is it's a restaurant food delivery robot. And the robots drive around restaurants, they deliver food to the tables. They do not pick and place the food, they merely deliver it, which is hard enough. And we're gonna pick on them because they're one of the most successful. They've got 10,000 robots and tons of people, so that's cool. One note before we continue, the talk slides will be posted somewhere, hopefully. If not, they'll be sent to the mailing list, so you don't have to like record the presentation. Also, you can ask questions during the talk. When we get to the end of the talk, there will be another period for questions, but you can interrupt me and ask questions during the talk. Raise your hand, I'll call on you, etc. Okay. So Cobalt Robotics, another example of robotics-as-a-service company. They are a security control robot. Relay Robotics does indoor delivery in hospitals and hotels. Hippo Harvest is a controlled environment agriculture startup, all automated via robots. Chowbotics slows down, but there's other things like it out there. They do salad synthesis on demand from the ingredients, so everybody gets their own personalized salad. Then AutoStore is a storage solution. So they have these bins that go into it, and you can basically automatically put and retrieve bins. And it's like S3 for the real world, but it's commonly used in warehouses and things, and they are now operating as a robotics-as-a-service. So why might we want to use a robotics-as-a-service business model? For the customer, avoids a high-risk experimental technology purchase and integrates the maintenance and updates and contracts into the robot. A lot of our customer targets, like restaurants, hotels, they do not have a plan for, they've never bought robots before, so they're not going to be able to manage the maintenance and things. They can just sign a contract and forget about it. They're going to like that. It's going to ease their accounting because it can replace an existing line item, so they can look and say, we're paying this much per month for labor, or we're paying this much per month for robot. And this is a weird one. It can potentially accrue tax advantages by strategies of between asset and expense. And that flexibility can help you do tax maneuvers that people like to do. So for the robotics-as-a-service company, it's going to facilitate your sales process because you can basically give people a free trial or a low-cost trial. It's going to have some predictability of the revenue and the pricing. You know you're going to get a check every month. And it entices investors, especially around here. A lot of investors really like the idea of a subscription service instead of a one-time sale. Carrying on. So what are some example pricing models that we throw around? A lot of robotics companies, by far the most common one is a subscription model where you just pay a fixed cost per month for the robot and for the servicing of that said robot. And this is the most common model, like I said. Then there's the pay per action model where you basically get the robot for free and then you get billed per action that you request the robot to take. So this is very similar to the model that Xerox used when they first sold the copiers. They basically gave away the copiers or sold them at low cost, then charged per copy. People bought them and they made very large numbers of copies, and then it was a large bill for Xerox. Okay, then there's selling goods made via the robot. So you can sell, you can just simply sell goods via the robot, similar to like a vending machine would, and split the revenue with the owners of the building or whatever, or the venue. Or just sell the goods on them. Okay, so typical costs. So what are the costs that you're going to pay to make that nice $1,000 a month check for doing nothing by sending out the robot? Well, first of all, you're going to have the parts and the labor for the robot. So there's a lot of money spent on basically that, and the assembly and the workspace, the testing, the validation of these things. There's a whole production process you're going to need. The shipping and transportation, obviously, sending these things out, bringing them back. All the traditional marketing, sales, taxes, and the business stuff. What we're going to cover a little bit more in detail is the certification costs, like getting all the certifications you need to be able to sell these things legally, or at least rent them out legally. And then RaaS companies tend to have additional costs that traditional robotics companies do not have. So one of the big things that is in RaaS that is not in traditional robotics is that every Robotics-as-a-Service company is also a software-as-a-service company. So there's a whole complicated cloud architecture infrastructure that is built up to talk to these things and remotely manage them and access them and all these things. There's also going to be a large geographically distributed team to manage and operate these things. You're going to need people in like every city to show up and fix the robots. And we'll talk about how big that team is next. And you're also going to need customer service and support costs that are going to be higher because you're dealing with less robot sophisticated customers. So you're going to need more responsiveness there. Okay, so why might you not want to go for the RaaS model given that? So the customer might not like the idea that they don't actually own the robot. They don't like the control of it, lacking control of it. And they also are running the risk that the RaaS company just goes out of business. We all know that companies just go out of business and then everybody who's a customer is kind of left stuck. And then for the RaaS company, again, things we talked about previously, the increased cost of support and maintenance, the complexities of maintaining cloud infrastructure, and the challenges of the operations team. So the operational challenges, let's just work some numbers here. So RaaS right now, their robotics, they have 10,000 robots. We all, or probably will, end up going to the San Mateo Convention Center, Event Center, where Maker Faire has been and several other things. If Bayer took all of their robots out of their customers and put them into that environment, it would completely overwhelm the capacity of the building. You would not be able to walk around. It would use up all human capacity. It would just be robots driving around. So that's a lot of robots. Now, according to public information, they also have 200 employees. So if you think about it, 200 employees, 10,000 robots, that's 50 robots per employee. It's not like the incredibly high ratios that you'll see with software later on. Now, contrast this with iRobot. iRobot, they have sold 44 million Roombas total over their lifetime. And they've sold 5.6 million of them in 22 alone. And they have 1,250-ish employees. So they basically are selling 4,460 robots a year per person. So those ratios are almost 2 orders of magnitude there. Contrast this again with pure software. Facebook, and this is a little bit rough, has over 200,000 users per employee. And Notion, which is one of those project management app things, has over 350,000 users per employee, roughly. So those numbers are, again, 2 more orders of magnitude on approximation. So that's an obstacle for scaling the company. So how do RaaS companies tend to work these days? Well, most of them go through the traditional Silicon Valley startup pipeline that every other company goes through. The details of that pipeline and how to deal with these investors is outside of scope of this presentation. And so this is just some roughish numbers of how these rounds might go. You'll have an angel investor round, raise under $1 million, 1 to 4 people starting off. You'll seed round, you'll scale up. Each round you'll scale up to more and more. Eventually you'll start outsourcing your operations and spreading across different jurisdictions and spreading out around the world. And then finally you'll get to the point where hopefully you don't need to raise any more money and you can either IPO or sell the company. And it's always best whenever you start a company to figure out who you're going to sell it to. Okay, so I'm going to talk about some common challenges for companies, robotics companies. Some of this information applies to anyone who's interested in commercializing one of their homebrew robots. So I'll highlight that that's that. Some of this is only for RaaS companies. So we're going to talk about the reliability and scaling issues, and that's one of the biggest differences between like hobby robotics and out the door is you need to have a much lower reliability tolerance. And then also the legal and the certification issues, which there's some surprising ones. Okay, so what is the impact of robot instability upon your company? All right, so let's assume we have a robot with a slow control loop in it. A lot of the robots we do around here are 10 to 20 hertz control loop. I've seen, you know, medical robotic stuff gets to like 1,000 hertz or more, and you know, high frequency control is also something people do. But here, you know, 1 hertz is very slow. Okay, almost unrealistically slow. Now, imagine that there is an issue where there's an issue that requires human intervention, and every time you go through the loop, there's a coin flip as to whether that issue occurs. So in some cases, it's unlikely, which is only 1 in a million. And then it's very unlikely, it's 1 in a billion. So 1 in a billion cycles through the loop. So 2 questions for the audience. How often do these issues occur? Both with on one robot and at scale. And if it takes 10 minutes to fix it, let's say someone has to log into the robot and do about 10 minutes work to bail it out whenever it gets stuck. How many people do we need to fix it? So now one of the things is if we go out and we grab like software people who do pure software or consumer software off the street, Facebook crashes 1 out of a million times we open it, no one cares. So the people often say this isn't worth fixing. Is it worth fixing? Anyone know the numbers here?
No.
What are the chances? It's very much worth fixing. Okay, so the unlikely issue, that's going to happen every 12 days for one robot on average. By the way, there will be the slides will be posted. And the very unlikely issue, that's going to happen only once every 31.7 years. So just remember, everyone, you turn 31.7 years old, that's your billionth second. I celebrated mine recently. Now, how about when you start scaling up to 10,000 robots? Well, the unlikely issue is going to happen over 850 times per day. And the very unlikely issue, it's going to happen like about once a day-ish. It's really about 1.1 days. It doesn't really matter. So now imagine that we have, I said it took 10 minutes. You have to do 10 minutes of work. It's not a big deal, right? To fix it when this happens. Well, it's going to take 25 employees. If they're working 2,000 hours a year, which is kind of like a rough estimate, they're working 2,000 hours a year. It's going to take 25 employees SSHing in, fixing the robot for the unlikely issue. So this needs to be fixed because that's 10% of the company or more out just doing this repetitive task to bail out all the robots every day. And so that's all it takes to really ruin you in terms of reliability. Okay, and so let's compare this with an off-the-shelf industrial arm. Some of these things achieve 10 to 100 million cycles without failing. So you'll see like the car, put in 100 million car doors or something like that on that order before there's a failure. So that's the constraints, and the implication in my experience is that the company with the simplest robot wins because less complexity means less problems. Okay, so another thing that hobby robotics didn't have to face, I didn't have to face this until I started like trying to sell stuff, is certification. So certification is things that you're legally required to get to be able to ship a product of a certain category. And basically, all the certification process works is you design your product to a set of predefined standards. Sometimes it's easy to figure out the standards because it literally says in the federal code you need this exact standard. Sometimes it's more difficult. That standard's a public document. You have to design that standard. Then you have to go to what's generally a government licensed laboratory to validate your compliance with that. And you have to pay them to do it. And then if you change the design significantly, you have to revalidate that. And the significant varies depending on what standards and process and all that. And then also in each new jurisdiction, you're going to end up having to recertify. So there's some things where there's like parity agreements where if it's in one, it's okay in the other, but not always. And again, I am not a lawyer. I'm not trying to help you figure this out for yourself. I'm just giving you a taste of what you're going to encounter, okay? We must remember Bill Benson's law Anyone can sue anyone at any time for any reason. So what are some legally required?
Shout out to
certificates?
Bill Benson.
Yes. So what are some legally required certificates for robots in the US in general? First of all, FCC equipment authorization applies to pretty much every electronic device we build. So that's one. Then there's the NTRL certification or NRTL certification. Sorry, I always mix the letters up. And this is required by OSHA for anything that goes into a work environment. And so if you don't, this is designed to prevent you from like burning down your house by having an electrical fire or creating something where there's sharp edges and people get hurt or something like that. Now, the really difficult one that really can get people is the safety critical software certification requirement. So this may or may not, depending on what you build, end up being required. The basics of safety critical software will be talked about in the next slide. We're going to do a whole slide on that. Now, in addition to all the legally required certs that the government's going to require you to get, people also try to buy insurance, either the robot company or the customers. They either opt to buy it or are also required legally to buy it, like workers' comp case. And that might require additional certifications. And some customers just demand additional certifications, even though it's not required by their insurance companies. And especially true with larger customers. So a lot of people try to focus on small business first to get around this. Okay, so a little bit of a deeper dive on safety critical software certification. So here's some great examples of safety critical code in a RaaS robot. What is safety critical code? It's code where a bug can lead to significant injury of someone or to property damage or whatever. So a great example like that will be obvious is all the code in the self-driving cars, or at least something is safety critical. In the case of all the robots that we're trying to ship, things like the lithium-ion battery circuit that protects the battery protection circuit, solution there might be to try to go for an off-the-shelf one, but if you implement your own, that's going to be safety critical because you can blow up the robot by overcharging your batteries. Another one that's very common and is surprising is the code for preventing the robot from driving off cliffs. That's actually one of the biggest hazards is this thing drives off the stairs, falls down the stairs and hits someone. Okay, so what happens when we have to do safety critical code is that we have to develop a detailed review of the code and more importantly, the software development life cycle, as it's called, which is the testing procedures and the process around deploying the code and the controls and changes in the code and all these things. And then there's also, in some cases, enforced coding style rules. To give people an example, this may or may not apply, is you're not allowed to have unused code, which is one of the standards that comes up. And so you can't have a function in there that doesn't get called. There's also the need for doing what's called hard real time. If you have just like your laptop, the scheduler in there can just decide to wait 20 minutes before it runs a piece of code. But that's not acceptable if that code needs to run fast to be safe, to respond to a safety event. So when you have that safety response coding, you have to do hard real time. Now, the fun thing about the club is that we're all working with microcontrollers, which is essentially what hard real time coding is like. So we're all got a leg up on it for doing that. And the implications for RaaS companies, there's a lot of them. Yeah.
So the hard real time is you just run a microcontroller.
That's one way to go. There's also, there's other options for hard real time. This safety critical could be its own talk, by the way, and I'd be happy to give a talk on safety critical certification, but I don't think people will be excited about that. And then, so one of the other implications of this is that it's really impossible to certify direct control via machine learning. So what happens is people have to put a safety critical certified guardrail layer in front of their machine learning. And you have to be really careful about that. And that's one of the things where it's like, you're like, oh, I'm just going to have my robot completely controlled by machine learning. Okay, great. That may work, but better be not a safety critical system. Okay, and then you also want to minimize changes to your code at scale to avoid recertifying the code. So shoot for that. And you oftentimes, most people, they end up having a separate physical processor for the safety critical stuff. So a lot of people do Intel NUC as their compute layer, and that's connected to an STM32, which is their safety critical processor, something like that. And you really have to, as an organization, have to know how to do this and make sure you're on the ball with it. Otherwise, there it is. Okay, really surprising thing that comes up. Another one, privacy laws. So in many countries, an increasing number of places, you have to be careful about collecting personal data as a company. And that means images of people and spaces and things, images of people's houses maybe, but definitely images of people themselves. And when you do that, you're then subject to requirements to be able to delete that information from your system and to be able to audit that system to show that you've actually deleted it and that you know where your data is going. You can't just have like random things full of personal data floating around anymore. And so we have to create procedures. The other issue for this is for AI. So with AI, when you train a neural network, the personal data that gets trained on, well, any data gets trained on, but generally personal data, also copyright data, time of personal data here, makes it into that network. And then there's a question of how can you get it out? Because if somebody requests their personal data be deleted, how do you get it out of the network? It's also worse with generative AI because it's easier to get the data out of it. And the answer in often cases is simply to delete the network, delete the personal data, and then retrain the system. That's the naive approach. People tend to try to anonymize the data, which is where you blur faces, remove people from the data set. And one company actually built a physical barrier around the robot so people could not make it into the data set because the robot couldn't see them anymore.
Hey, Tony, if I hear you right, this is kind of like a cloud setup where somebody's doing this stuff and then it becomes
yes.
Then it becomes regulated in this way.
Yep, you're doing a cloud setup where people upload data from their robot. This is where that starts hitting.
What if the data were local?
So it could still hit in that case. The question is, what are you doing about if somebody sends their robot in for servicing? How are you handling the data that you get off of it while you're servicing it?
So you're still potentially liable even if the data is all local and stuff.
Yep.
It seems a lot like the GDPR laws.
Yes, this is GDPR and CCPA.
But Europe is almost.
Well, Europe is GDPR, California is CCPA, which is gradually expanding to be GDPR. It started as GDPR light and now it's catching up. Okay.
Is the football outside of California residents?
Yeah, because there's starting to be clones of it in every other state. So like gradually states are signing things and everybody's out of sync right now because they don't, people don't keep updated with all 50 state privacy laws.
Does the robot need to constantly ask if it's okay to use cookies?
No, maybe like that's a lawyer question. I'm not gonna answer that. Yes, well, okay. So that's the basics of RaaS issues. I'm going to talk about my lessons learned now. If no one else has any questions on litigation. Okay. So lessons learned from working in RaaS companies. One, you better really develop a good understanding of the target market. If you do not, it's not going to be a great experience for you. One of the things you want to do is really understand the cost structure and the performance requirements. If you're making a robot to flip burgers, you need to understand exactly how much it costs to flip each burger and how much it costs to do it in each jurisdiction, what the acceptable failure rate of this is, what the different types of failures are, et cetera, et cetera. All the specific legal requirements need to be understood. If you need a license to flip burgers, you better figure out how the robot's going to get it before you try to ship. You also, and what I've seen work really well is to have a partnership directly with people who have done business in the target industry. So if you're trying to do something with restaurants, a partnership between a robotics CTO and a restaurant CEO is like, that's how you ship. Okay. This is and by the way, these are ordered in order of how much damage they do to your company in terms of the lesson. So in the second one is you need to keep your engineering team focused on engineering, not fixing individual robots. Once they start doing that, a lot of those problems are caused by underlying design and coding issues in the robots. So if your engineering team is off trying to fix individual robot problems, they're not fixing the underlying problems. And eventually you're going to use up all your engineering time as robot problems multiply, and then you can no longer ship updates, and then you can't really grow as a company anymore. You're kind of stuck, and you have to grow. So, okay, RaaS. Really is a good idea to use RaaS. It's going to save you years of effort. All these people come up to me and say, we can't use RaaS because of this. It's too slow. There's too much multi-processes. There's, you know, some unspecified timing issue that doesn't seem to affect anyone else, but they always say, can't do it. There are 20,000 plus robots shipped out there using RaaS, maybe even more. Yeah?
Add some zeros.
Add some zeros, says.
All our robots are 7. All Rubas are 7.
Okay, that's public, then that's like, what, like 5.6 million of them? Okay, according to the previous slide. So millions of robots have shipped using RaaS. So don't be afraid to use RaaS. And then the other thing people always say is, oh, some proprietary framework's gonna win. You know, when I was working at Willow Garage back in like 08, people were always like, well, Microsoft Robotics Studio is gonna win. Microsoft has so much more resources than Willow Garage. I don't get why you're doing this. And does anyone ever actually even know about Microsoft Robotics Studio anymore?
No.
Oh, some people
That's a
remember
name I haven't heard in a long time.
Yeah. Okay, yeah. So anyway, you know, basically Microsoft, NVIDIA, and Google gave up. So if you might also not want to go down that road. Yeah.
I've said this, I think people have probably heard this, I don't know if it's before, but I'll just repeat it again. Every argument I've heard about why not to use RaaS and all the problems with RaaS, I heard like almost 30 years ago about why you shouldn't use TCP/IP and why OSI was something in.
Yes.
And everybody that argued against it was sure that they were going to ship like an OSI stack any day now, and it was everything was, you know, TCP was going to follow Ryan's speed, and Cisco and Netgear and Juniper, everybody else went off and made like billions of dollars, and they were still hacking away.
Okay.
At one point, early in my career, I was working for a system contractor,
and they were using OSI?
Not use OSI, and I had to fill out a paper form with a justification for, because I was a government standard, you had to fill out a paper form like why you couldn't use it. And eventually just the paperwork overload from everybody.
Well, if only they had an auto store to put all that paperwork in.
Sending them in, it's like, okay, you give up.
We give up?
That's still the OSI right there.
Yeah, okay, well, anyway, so that's one. Another one that I've seen is plan for parts to become unavailable. This is an issue that happens in hobby robotics, but it's really bad when it happens in a company. For example, imagine your microcontroller line goes out of stock and now you have to rewrite all your firmware. Not a good experience. And so if possible, you want to try to have multiple suppliers. You also want to be aware of suppliers that provide part availability guarantees. So one of the reasons why STM32 is such a popular microcontroller is because they guarantee like 10 years of availability. If you look on the website, you'll see like 20-year, you know, you'll see it won't go out of stock until 2030 or something. So if you use that, you're probably either you're going to be big enough to be able to get a new part or you're going to be out of business by then. So don't worry.
As opposed to Intel's guarantees, we will stop shipping this 2 months from now.
Yes, Intel's guarantee, and then they are like, actually, we don't really feel like it. You know? We looked up and the weather was nice, so we decided we're going to keep it around. Yes, it's very stochastic. It's a stochastic process. Yes, the guarantee is going to be an exciting experience for you. So then the next one, the last thing is if you can't guarantee it, this happened with the Kinect because we had 3 generations of Kinect where it went in and out of stock, in and out of production. Everybody kind of knew after the first one that it wasn't, you know, this was going to happen. So people stockpiled Kinects, and circa 16, 17, you would go to robotics companies and there would be pallets of Kinects hidden by blankets, stashed away and build enough robots for the company to get big enough to afford to create our own depth center. Okay. So this is some trade-offs that happen that are kind of interesting. So People oftentimes think, hey, we could put redundant systems in the robot, have 2 sensors instead of 1. That would make it more reliable in case one of the sensors fails. That's worth investigating, okay? But it also can come with costs. There's complexity in the software of deciding which one is good and which one is bad. There's the complexity of figuring out when it's bad. That may or may not be difficult. And then there's the additional complex cost of having 2 of these sensors. So it's worth considering whether that's worth it. And it might make sense to pay for 1 more reliable sensor than 2 unreliable sensors in some approach. Okay, another thing people often question about is whether they should make their robot modular or have a singular robot. And there's trade-offs both ways. So imagine instead of having 1 circuit board in your robot, you have 5 different circuit boards. And that way, if one part fails on one of the circuit boards, you only have to replace 1 circuit board. So that saves you money. But it can also increase complexity because you have different circuit boards, you have all the connectivity between them, you have the cost of managing and knowing which boards you have, and then you also have the cost of testing it. When you start getting different versions of the modules, then you can get into the combinatorics of, I have 5 different modules, I have 5 different versions, now I have 3,000 possible combinations, how do I test all of that? So there's a trade-off here. And the trade-off is very different. For example, in the space mission earlier, we were talking about the fact that they had another LiDAR, they could recover the spacecraft. You will not be doing, experimental software to recover 1 robot of your company. You will send them another robot, take back the robot. It's probably the trade-off that is much better. If it's a space mission, it's $10 million down the drain minimum. So doubling up makes sense. Okay. Geographic expansion. You want to be careful with geographic expansion. This is a gotcha. So people oftentimes try to do geographic expansion early. Also, people from software background, geographic expansion in software tends to not be as high cost. You basically are talking about rewriting terms of service, maybe onboarding some local payment processors, localization. It's not an extreme cost. Whereas with robotics, you have the shipping, the cross, entire new business environment, plus all the recertification. And also when you're starting out, you don't want to do a lot of driving if one of these things fails. So you really ought to start near your complex and then start moving overseas and out of state as things get, better. Okay. Lastly, trade-offs between physical and simulation. So this is my last lesson learned. So there's a lot of people out there trying to sell you on robotics simulation right now. The problem with that, and there's a lot of benefits to that. You could do automated software testing. We had this at Willow Garage where whenever somebody checks something in, it would automatically be tested on a pretty significant set of tests. And that was only possible because of simulation. You can do generation of data for AI training. You can do all sorts of experiments and prototyping, and you can do tests and things that are impossible to do in the real world on your robot. So that's all great.
Unsafe.
Yes, unsafe testing, all sorts of dangerous things. You have all sorts of fun simulation you can't do in the real world. But the drawbacks are that you're going to require 1 to 3 people working on it in every company I've seen. And that's a lot of people, especially when you're starting out, you don't have that many people to go around. And commonly, I've never seen simulation get good enough to replace all real world testing. I've seen it be able to supplement real world testing, but I've never seen one good enough to replace it all. And the question should be asked is is it worth me to commit to simulation early, or is it worth me to just double my real world testing budget? Because I could take that one person on sim and just have them do real world testing. So it's worth considering which way you're going. Okay, so we've got 2 more slides, then we got questions. So future of RaaS. Right now, it's getting easier and easier to build a RaaS company because you have all this off-the-shelf stuff that you can just use, and that's super exciting. So hardware-wise, right now we see with the basics. So if you look at a lot of these mobile RaaS robots, they all have a disk drive base with mapping and LiDAR from RaaS. Okay, so that's starting to become a genericized product where you can just buy bases off the shelf. There's the Zebra/Fetch AMR bases that are out there, and there's starting to be these compatible alternatives. And I know a lot of people are just grabbing the Fetch AMRs and building stuff on top of them. multiple companies. There's also the Hello Robot Stretch, which we talked about earlier. That's not that super expensive compared to a lot of other solutions. And so I think we're going to see the possibility of a pure software robotics as a service company relatively soon via programming stretches or something similar to the stretch. It may not be the stretch itself. And then we're also getting software that's really helpful. So there's the, this is also something that's worth investigating for hobbyists, is things like Tailscale and Go Teleport, which allow you to remotely access your robot easily. So if people are doing stuff with RaaS, that might be worth for people in the club to check out. Then there's Balena and Talos, which are these auto update instructors, and there's starting to be more of them that are available. And that's actually a big problem, is how do you update all 10,000 robots and keep them in sync? And it becomes a big problem. Then there's, well, we're in Inorbit H2 right now. So I want to thank Inorbit for hosting. They have the fleet management as a service software offering, so you can try it out. And then there's also this interesting company that's doing called LabScale. They're doing hardware in the loop CI/CD. So you have a fleet of devices, and every check-in to get gets tested on. So it gets auto-tested on one of the devices, and they manage all that logic for you. So that's one of those things that I was talking about earlier about testing software versus hardware. Anyway, so that's the end of my talk. Now I will take your questions. I will take online recorded questions now, and then I'll stay around for a while and take like offline questions if people don't want. Thank you, everyone. Thank you.
Thank you, Tony.
Well, I have a question.
Okay, we'll go internet and then you.
Okay, cool. Well, thank you so much.
Can you stop sharing screen, Tony?
Oh, yeah. Well, how would people know how to ask questions if I stop?
We got it on the chat.
Did it stop?
You're good.
You're fine.
Yes, the infinite recursion. Okay.
There's like a 2-second delay on every frame.
Do that again.
Yeah, it's a loop. I was messing with it earlier in the back. So. Okay, well, we are easily amused, as Cam likes to say. Oh, okay. So questions from the internet and then from you.
Okay, I'll go first from the internet. Hi, Tony. Thanks so much for this very thorough presentation. Really shows that you've thought deeply about all these different issues, you know, that RaaS
for 7 years. So
out of RaaS, yeah. I suppose, like, my question is, like, what branch of robotics are you sort of excited about that you think can have the most impact to empower individuals? Because the narrative, you know, at least in Hollywood, is like, you know, it's going to replace humans and AI. So where do you think sort of like robotics can sort of empower individuals and sort of a positive, optimistic narrative?
Oh, yeah. Okay. So I think that's a great question. I think the next thing for robotics, there's a mixture of it. I think the next thing for robotics is sort of more and more larger scale teleoperation initially in like dangerous environments, and then more into like annoying environments where it's like expensive to live and you can remote control into it. And then you also will get more, that'll be the start. And then we'll also see more and more sort of appliance-like robots, I think. So like, I think specialized robots is where to go. And I think there's so much low-hanging fruit with specialized robots that it'll be a long time before we have generic robots, just because there's so much money to be made on very simple specialized robots still. And I think all repetitive tasks will eventually be automated and we can do other interesting things. That'll be great.
All right, thanks.
So one last part, there's also, I think, another target. And if I was like, if you're a roboticist today, I think your #1 target should be something that's either impossible for humans to do or something that damages people's bodies when they do it. Like, you know, literally back-breaking manual labor, automate that stuff so people don't get messed up. Okay, well, we have you first. There's a queue. So you, and then Rohan, and then you. And then you. Okay, you. Sorry, I don't know your name, so you're just you.
Two-part question about certification.
Yes.
So are there like ISO standards that apply?
Yes, ISO and IEC standards are gonna apply, and there's some ones that are just literally the robot standard. Those are mostly in Europe for the ISOs. The UL standards are clones of the ISOs that are switched up a bit in many cases.
Okay.
And it's like UL, whatever. By the way, this is a clone of ISO, whatever.
Okay, and are these standards about legally being able to put the robot in production?
Yeah.
Or are they about limiting liability against?
So a mixture. So you're going to have ones that you cannot ship without compliance. And then you're going to have ones where if you, that are a liability limiter. So basically when there's a battle of expert witnesses in the case, that's ammunition for your expert witness that you complied with that standard. Yeah, okay, next up was Rohan.
What's your take on robot costs and how it relates to the feasibility of robots as a service?
Oh, robot cost is a big problem. So cheaper robot wins and simpler robot wins. So always think in terms of the simplest possible option. Well, we got your next.
Yeah, within the queue.
Okay, yeah.
The quick thing was, my first robot company was in 77, where my wife challenged me, said, if you want to sell 1 million robots, make a robot and clean the toilet. Since then, I'm trying to do that.
Yeah, that's a great, yeah, I've actually thought about this in the sense of a self-cleaning restroom module.
Yeah.
You have it assembled a priori, either as like a standalone or something that gets dropped into a building and it's self-cleaning with robots. That's what I've been thinking. What's up?
You mean a hose? Well, yeah, that's what you need. Yeah,
That's one option, but yes, you can do things that you can't do.
Power spray.
Okay, Ted. Yeah.
You're saying.
Sorry, I shouldn't use your names. Privacy risk. Go on. I don't want to get sued.
That's all right.
Too late. Yeah.
Talking about certification, you said that, becomes a problem with machine learning. Do you think the industry will soon find a way of standardizing like machine learning or?
I think there will be a fight between people who just want to let machine learning run wild and people who are like on the certification bodies who don't want people to die because machine learning goes wild.
Because I can see like you have like somebody like taking a test after they learn something.
Yeah, so like I think the problem is that there's a lot of analogies on the internet that people make between machine learning and people. In like the legal context of safety critical certifications, they don't care about that.
No, I
So,
understand
like, yeah.
that, but as far as like, do you think the industry will
I think
figure out
there's
how
some,
to do it?
yeah, so I think what's gonna happen is you're either gonna have to certify somehow that you're gonna treat it as a black box. This is what happens now. You're gonna treat your machine learning as a black box and prove that in empirical scenarios, using empirical testing, it performs well enough. Because it's not entirely a like hard and fast rule that it can never make a mistake. There is some tolerance, but it's going to get to the point you have to prove that it beats that. In some cases, there may or may not, depends on the standard. And then in other cases, you're going to take a robot, you're going to take something in front of your machine learning that prevents it from doing anything bad. And if you do that, then the machine learning can just go do whatever it wants. It can try to say, go to the moon, and the robot can be like, no. And so that's that. Yeah, so that's what's gonna do.
Okay.
Yeah. Then Rohan, I missed you, right? Or did I get you? Okay, I got you. Okay, next to you.
Same topic, and I don't know how you could dive into it, but I was wondering, do the current regulations specify anything beyond like movements that would or protecting against movements that would damage the robot or
damage? Yeah, so damage to the robot is less of a concern. That is more of a business concern in the sense that we don't want the robots to damage themselves and then have to spend money to fix them. The main concern is damage to the customer's property as a number 2, and the number 1 is injury to people. And that's what the law is intended to protect against injury to people.
How does the law protect it? What do they require to be determined?
There's some, that depends, but generally there's like a hard requirement of determinism at the safety critical layer. So like, you can imagine you have a rule, the robot's allowed to do, the AI is allowed to do anything it wants with the robot, but there's a force limit that's deterministic, that you can't apply more force than a certain amount at a joint. And then no matter how that person, a person gets pushed by the robot, they can't be injured by it. Or in the views of the law, they can't be injured.
So if you train
It's
a
always
robot-
possible, but yeah.
If you train a robot to do a task, but the force is deterministic. then-
Well, potentially, again, what I'm saying is you have a deterministic layer protecting you from ever generating say, a dangerous event. So you're saying, okay, what is a dangerous event? Just pretend that, throw away the AI for a minute and pretend that we have a malicious individual behind the keyboard, the robot, and they're trying to cause a dangerous event to occur. So you have a deterministic layer where the person is doing malicious stuff. They're mashing the keyboard and they can't do anything. That is what you want.
You gotta try.
Okay, cool.
I wonder if it's recognizing your gestures or something.
Who knows? I'm just gonna assume that. Okay, who else is, okay, we have one, wait, we have you? Yeah.
Yeah, so you mentioned you think that there are interesting opportunities in specialized robots, right?
You can't.
What are particular like vertical industries and opportunities, and what is your take on creating a business B2C versus B2E? Right?
Okay.
Because B2E, I think go to market is much easier, and probably you have more control on the environment, right?
Yeah, so B2B, there's tons of it. You just have to know the industry to really start to see what's going on. And you have to look at the robotics problem. I mean, the toilet cleaning one is still outstanding, right? And that's a very specialized robot. It just needs to clean a toilet. It doesn't need to do anything else. I would advocate for cleaning the toilet and the shower at the same time as a product, but let's just pretend, right? This is one specialized robot. Nobody likes cleaning toilets, right? So that's one specialized task. So there's a great example of a specialized robot. I think that the generalized robot is just very difficult, and I think it's much harder than is expected. And and there's just so many obstacles to it that's not going to happen. We've heard a lot about how, we've had a copy, before there was a computer in every home, there was a copier in every office. Let's focus on that. That's where I would advocate. In terms of B2C, the big challenge there is cost. You have a hard cost floor. There's a top cost limit of about $1,000 maximum. There's probably a limit there's probably a product that can be made that's roughly $5,000, but it's not something like that. But that is not a hobby, that is a prosumer product, so it won't be mass market, where it's basically the target market is software developers, because software developers are now like one of the richest, the largest group of people with disposable income. And so if you make a robot that is designed for software developers to have fun with, there's a higher bar there, but everything else is probably just too low a bar right now for anything besides toys. And with toys, you have the challenge that you're basically competing with video games who have 0 unit cost. So I'm not very big on B2C because of that. And also I'm just not very good at B2C as a person anyway. So I focus on B2B. Yeah. It's you.
Yeah, so it looks like there's a lot of action around humanoids at this point.
Yes.
Based on what you're saying, you brought up business.
I'm a hardcore AI and humanoid skeptic. And one of the reasons why I'm very skeptical about humanoids is that there's 2 reasons. First of all, they're incredibly complex compared to robots. So first of all, most of the humanoids, it might make sense to have a wheeled base and human arms. That's generally the first revision, and that saves you massively. The only reason for the legs is to do stairs. Most commercial environments don't have stairs because it's illegal for them to do so under the ADA. So that's when things like Willow Garage people always said, oh, you need legs to do stairs. And we're like, no. And the fix for it in homes is if you have a home where there are stairs and people are willing to pay $500,000 to put a robot in their home, they're also probably willing to pay some number of thousands of dollars to put in a stair. So that's problem 1 with humanoid is just the complexity. The other thing is the danger. So one of the things that's very dangerous about humanoid is imagine the robot just falls over. And it'll fall over and somebody's there, they're going to get hit, and that's going to be a lethal hit because that's a 100-pound robot. They also have to be very strong to be able to stand up. So if you get kicked by the robot, bam. And so now there's a huge safety critical software engineering problem. And if you want to direct AI control these things, I think we talked about why I don't think that's going to happen. And that's that. The thing you see a lot of in the humanoid environment, robot demos, that's kind of one of the hidden things in there, is that there's a lot of barriers put up around them. And that's the way to get around the safety critical issues, is basically to have a human out environment and shut the robots down when it's in. And people want these things to exist in human spaces. The other problem, the other reason why the stretch is so cool and why it's so popular right now is with arms. You also have a massive safety critical certification problem, because imagine you have an arm that can lift that cable. That's 1,000 pound, you know, let's say it's a 100-pound cable. That means it can also apply 100,000 pounds to you. And 100 pounds is enough to do some damage. I think the weakest point in the human body is like 70 pounds limit, but it's much lower than that in practice, before you cause injury. That's to cause death. The weakest point humans actually here. The second biggest weakness, the other issue with humanoids is like another hazard with them is they can poke you in the eye. And that's like a hazard that comes up. It's like eye poke out. So you gotta be careful with it. So stairs, eye poke out, crush hazards, pinch hazards, I messed around with one of the stretches and I tried to get it to hurt me. So I tried to, you know, sorry Stretch HQ, I wasn't gonna sue you, don't worry. I tried to put my fingers into the gear train of the robot and into the motor and stuff, and I couldn't get injured. So that's a huge win right there. And that thing can still lift a lot of weight. I mean, it can lift the full Coke can, it can lift tons of stuff, and it's not an injury hazard. It's going to be easier to safety critical engineer it to not injure people.
Excuse me. Will you like some more?
Oh, I'm good. I'm good, but thank you. Thank you. Yes.
I had a question.
One more, and then we go to the chat.
Just want to make one comment about this whole testing, using AI systems for certification. Some standards allow you to show that you can achieve level 1 failure every.
Yes, that's the black box certification standard.
Yeah. The problem there is like having a data set of 10 to 9 hours becomes tractable.
Yes, exactly.
So you have to play clever tricks there.
Yeah, you have to start talking about synthetic data and all these things to prove it. And then it's like, by the time you start doing that, it's worth investigating. Like by the time you build out that infrastructure, it's worth investigating like classical algorithms can maybe do that a better job.
Yeah, so one of the questions I had is you said humanoids are generally dangerous. But do you think that applies to all dynamically balancing robots? So if you have like a two-wheeler, for instance, is that you consider that?
They're as dangerous, but the advantage of the balancing robot is that they're easier to control. So there's possibility of building a deterministic control algorithm to control them easier than the humanoids. The challenge with the other issue is why have a two-wheel balancing robot? Because like you could just put like wheels in front and back and then like call it a day. And so like the only reason to have a two-wheel balancing robot is again the stairs issue, but that's not an issue, so who cares?
Okay.
And, the other way is to have a light robot, you'll see like light humanoids, like tabletop ones, because those can't injure, they're just not big enough to injure someone.
Yeah.
Tony, you've covered dirty, dull, and dangerous as being kind of the spot to be in. I know warehousing, pardon?
Annoying.
Okay. Oh, annoying. Okay, let me add that in. Warehousing right now is a real hot market for robotics. What do you think is the next really hot market with potential, like grocery stores or hospitals or construction or
farming?
Farming?
Yes.
Yes, farming is there. And farming with robotics, you can kind of enable new ways to do farming that are also helpful. Like, for example, one of those companies doing the controlled environment agriculture thing, and you couldn't do that without robots. At least it wouldn't be very profitable. I mean, you could do it, no one would want to pay for it.
You can do planting, picking. You don't have to do, you can do like very precise pesticides, or you can just burn things with a laser beam to get rid of them. The whole, that's a big world, big world.
Laser is really dangerous, so propane, but yes. It's too easy to hit a glass shard and then hit someone in the eye.
I just want robots with laser beams. I don't know. That's what
What do you want? Oh, well, yeah, there's no reason why you can't build a laser robot.
That's Steven. Steven wants robots with flamethrowers.
Well, yeah, that's possible too.
Already got that.
I'm not gonna be signing up to help you with your safety critical certification.
Don't encourage him. Any more questions on the Zoom call?
Yeah,
Then we got one IRL.
robots
question.
robots that work in hospitals or food prep. Don't they require additional certification for sanitation?
That can come up. Yes, I'm glad you asked. So with hospitals, depending on where you are and how much interaction you have with the patient, that may require FDA. There's just other things. I don't know the details because I haven't worked on that specifically, but that may trigger an FDA review process. Hopefully it will not. In the case of, there's the issue of like pens in hospitals, I don't think have to be FDA certified, like the pens, I'm not sure the details on that. So, and then for the food prep robot, yeah, that may come up as an issue with that. It depends on that. I don't know the details on that either. But if that's like, yeah, that's an obstacle if you're doing it. And also the other thing about food prep is I believe that's regulated at the county level. So there could be, you know, now 2,000 plus certification costs.
There's one I saw.
Yeah.
Are certifications required for defense application?
Yes, and additional ones are required by the military, and there's military specific ones. They also require a lot of cybersecurity certifications too, because you can't have a hackable drone army. You know, and you won't have a drone army. well, someone will. It won't be you.
Is that it?
Okay.
Very complete, Tom, thanks.
Yeah, going for the best. So I'll be around asking questions.
Thank
Are
you,
we ready
Tony.
for Ray?
I'm gonna make a couple of announcements first.
Okay.
So the first and the most important is, thank you, Tony, for an excellent talk. Chris from InOrbit. So second, I want to thank InOrbit, and in particular Chris, for hosting us. Really appreciate the support from InOrbit. So this is the biggest crowd we've had since before COVID in real life, and that's great. And there's a lot of new faces here. So I just want to make sure that people
for the people on the Zoom call,
Turn
can
the
you
camera.
show the camera around so we can see who's there?
Good point.
it's taped. I can overcome it though. Okay.
Hey, guys.
Yeah, so a lot of people and a lot of new.
I know these
So I just
guys.
wanted you are aware.
All right. Rohan.
So the
Hello.
first thing, our website is hbrobotics.org. I hope you all have been there. Now, I messed up the cool acid trip effects. We'll work on that later. So hbrobotics.org is our website. There's a couple of things I wanted to explain about that. One is we have a forum where people post questions, comments, news. There's a lot of interaction there. You can learn a lot just by reading the forum. So there's a link to it from the homepage. The second thing is we meet once a month on the last Wednesday of the month. And 3 times a year, we have the meeting is dedicated over to show and tell. People bring the robots in whatever stage they're in. Don't be shy. We would love to have new people demonstrating what they've got, what they're working on. We have
Hey, can we get somebody working the camera there and put it on Dan's face?
Just sit down in the chair.
Are you thinking there's like a professional camera operator?
That's well, that's why I have to ask.
Yeah.
Yeah.
Okay.
That's awesome.
Yeah, so this is, mainly, I think that most of the new people are in the room, and that's why I wanted to take this second to just communicate about it. On March, month 3, 6, and 9, it's show and tell. And it's really
March,
fun
next month.
So do you have the date, Cam?
Yes, it's March the 27th. March the 27th is the last Wednesday of the month. It's going to be our HBRC Challenge Phase 1.
So come by, you'll see some incredible robot makers and have the chance to ask them how they did it. What were the hard parts? What were the good parts? What parts did they use? And Other than that, we have interesting speakers. You'll find out about those on the homepage as well. So I just wanted to let you know, and hopefully you'll engage. We also have the opportunity to join the club. It costs $10 per family per year. It's the best deal in Silicon Valley. You'll see a link on the homepage if you want to do that. Any questions about the club? If not, I think we'll go into random access.
Thank you, Dan. Thank you, Dan. Thank you, Ralph and Michael and everybody that helped set up. Thank you, Marco. Thus concludes this meeting. We now hereby go into random access. Testing 1, 2, testing 1, 2.
Turn off the recorder.
Yeah, turn off the recording. That was awesome. That was